This brief video is another in our series on doing things with geometric algebra, and in it we will derive Heron's famous and very useful formula for the area of a triangle, and we'll use geometric algebra for that instead of the classical version, of course. This video, I think, will be mostly self-explanatory, so I'll go through it fairly quickly, and then you can go through it on your own time afterward. So what you will see in this video, we'll start out by mentioning the geometric relation between the area and the norm of an outer product. And this is something that can be used very easily in GeoGebra, the free geometry program online. And we'll see here that the area of a parallelogram is equal to the norm of the outer product of the two vectors that form its sides. We'll also show the algebraic expression for the norm of the outer product, or the square of it rather, and at the end of this video I'll derive that. We'll also show here an expansion of the difference of two vectors and how to use that to obtain an expression for the dot product of the two vectors. So all of that is here. You can look through that at your own pace. So again, we mentioned that the area of a parallelogram is the norm of the outer product of the two vectors that form its sides. So, sorry about that. So then the area of the triangle here is half the norm of the two vectors that form these sides. So, continuing our formulation in geometric algebra terms, here we have the correspondence between the given triangle and how we will formulate the sides in terms of vectors. Note that instead of calling this side C, we're expressing it as B minus A so that we can use the identities that we saw earlier. So the area is half the norm of the outer product of these two vectors. We'll square that area so that we can use this identity that we saw a moment ago. So squaring that, the right-hand side here, we'll now make use of that identity to obtain this expression. Continuing on here, we arrived at this point, and now to obtain an expression for the dot product of the vectors A and B, we will use this other identity that we saw a moment ago, and in terms of the given triangle here, u minus v squared would be b minus a squared, which is the square of the length c. So in terms of our given triangles here, a dot b is a squared plus b squared minus c squared over 2. We'll make that substitution here to obtain this expression. And continuing on, we do a bit of algebra here, and we factor it, take the square root, and obtain the usual form of Heron's formula. So I hope this video has been useful, and I hope you'll consider joining the LinkedIn group Pre-University Geometric Algebra, and I'll post the link for that in the video description. Now here is the derivation of the formula that we saw earlier. The square of the norm of the outer product of two vectors is equal to, well, you can read it yourself. So here's the derivation, and you can go through that on your own time. Again, I think it's self-explanatory. So thank you for your time. I look forward to your comments, and again, I hope this video has been